So this is a little bit of an involved problem, but it's something that we can deal with together. So let's read through the question. It says that we have an object that is 20 centimeters left to a lens of a focal length of positive 10 centimeters. A second lens of focal length 12.5 centimeters is 30 centimeters to the right of the first lens. And they want to know what's the distance between the original object and the final image. So we want to measure from the original object to the final image. So I'm going to draw this out and try to label everything. So this is going to be lens 1 and it's lens 2. And I drew them as both converging lenses because I have positive 10 and positive 12.5. So positive 10, focal length 1, which is measured in this direction, and focal length 2 are the corresponding values. One of them is 12.5 centimeters, the other one is 10 centimeters. And we know the distance between these two objects is 30 centimeters. And we place the original object distance, I'm going to call this P1. P1 has a distance of 20 centimeters. So we want to know, where does I2 form, the final image? I have two lenses, so I'm going to have an image after the first, which is going to cause an image to show up after the second. So I want to know, where is I2? Well, I know that there's a general equation that says P1, or 1 over P1 plus 1 over I1 is equal to 1 over F1. The focal length of the first lens is related to the object distance and the image distance of the first lens. So when I plug in these numbers, I get 20 centimeters, 1 over 20 centimeters, plus 1 over I1 is equal to 1 over 10 centimeters. And 20 centimeters, this is 2 over 20, so this is 1 over 20 centimeters, this is 2 over 20 centimeters, which means that I1 is going to be equal to 20 centimeters, and it's a positive value. So if I were to draw this in on our picture, we would get our first object, or our first image, I1, to be 20 centimeters past the first lens. It's positive 20, so I'm on the positive side of the first lens. Now here's the trick on all multi-lens problems. And the trick is to measure, is that the image of the first becomes the object of the second. It's in the same location, but we measure them in different ways. So P2 is actually going to be related to the 30 centimeters and the 20 centimeters. So it's 30 minus 20 centimeters, or 10 centimeters. P2 is 10 centimeters. It's 20 centimeters, 10 centimeters backwards to get it. And it's a positive value because it's on the left of our lens, and this is where we get positive object locations for lens. So we're now measuring off of lens 2. 1 over P2 plus 1 over I2 is equal to 1 over F2. And when I substitute in these values, I will find that I get 1 over P2 is 1 over 10 centimeters plus 1 over I2 is equal to 1 over 12.5 centimeters. So I'm just substituting in P2, this is F2, and I'm figuring out what I2 is. And when I work this out, I2 will actually equal to minus 50 centimeters. So when I get the minus 50 centimeters, I need to go back up to my picture and see that minus 50 centimeters is measured from the center of this lens. So minus 50 centimeters is in that direction. And I want to figure out how far away it is from the original object. So I ask myself, well, where is my original object reference to this lens? Well, I see that my original object is 30 centimeters to the first lens and an additional 20. So my P2 with reference from the second lens is actually at a distance of minus 50 centimeters. So I'm measuring in this, P1. So I'm measuring this one to be P1 to be in a backwards distance of minus 50 centimeters. So these 2 points, the object, my image 2 is going to form way back here. It's going to probably be upside down because it's I think a virtual image. It's going to be exactly the same spot. 30 centimeters and 20 centimeters is 50 centimeters from the object to the second lens. And our image to from our second lens is in the minus 50. So they actually show up at the same point. It's kind of a weird case where the object, the original object, and the final image are at the same point, but it happens. One thing that will change in this problem, or that changed because of these two lenses, is actually this distance, or this image, is going to be a lot bigger. It's going to actually be, I believe, 5 times larger than the original height of it, and it will actually be inverted. So not that hard of a problem to go through. Solve the original equation for where our original image location is. Our first image becomes our second object. We got to remember that we measure them in a slightly different way, and then we figure out what our second image location is, and then we compared it back to actually answer the question.